Hey, I'm back, and today we will see the part 3. We'll continue with our part 3. So, we have to start with the development leading to Bohr's model. About Bohr's model, we have to study Bohr's atomic model. So, development leading to Bohr's model of atom or Bohr's atomic model. So, there are two main points you need to write in this. The first one is experiment which were done on matter by passing radiations give us some information. So here the main things are electromagnetic radiations we're going to discuss. So which was done by James Maxwell. Some experiments were done which gave us some information. It was done by James Maxwell through electromagnetic radiations, and this is also said that electromagnetic radiations possess dual nature, which is particle nature and wave nature. Okay, particle and wave nature. Second, what you need to understand is wait, go. Yes. Second, you need to understand is atomic spectra. What is atomic spectra? Hydrogen spectrum, etc. will come in this atomic spectra. Okay, so let us start. Yes, so we will see what is electromagnetic radiation. Electromagnetic radiations. Okay, by the word itself, you can see electro and magnetism. Okay, yes, so radiations which possess both electric and magnetic fields, which possess radiations which possess both electric and magnetic fields. It's nothing but electromagnetic radiations. What are some examples you can give? So examples are, you can go for gamma rays, okay, IR rays, that is infrared rays. Then you have UV rays, ultraviolet rays. You have X rays. You have microwaves. These are waves. You have TV and radio waves also. These are some examples you can give. Okay, now coming to a property of wave. What are some properties of wave? This is very important. Properties of wave. Most of the problems are solved through this only, which is wavelength. Okay, denoted by lambda. Then frequency, which is nu. Then you have third is velocity, which is v, but here we will use as c. Then we have fourth one, wave number, which is 1 by lambda inverse. And then fifth one is amplitude. This all is discussed in my previous videos. I'll give the link in the description. You can just check it out. So small a, don't write capital A. Okay, wavelength, what is everything is being defined in that video. You can just go through it. Okay, next, these are the properties of wave. Okay, so what is the wavelength? Still, I'll just give introduction for this, but if you want to see, you can just see. Wavelength is nothing but the distance between two crests or two troughs. This is your wave. This is your wave. This is your trough, right? Sorry, this is your trough, the below one. The distance between two consecutive troughs or two consecutive crests is nothing but lambda. This is also lambda, this is also lambda. Next, you need to know the units for the wavelength. Units are angstrom. Angstrom is a unit. Then you have nanometer, picometers, centimeters, and millimeters. Okay. coming to next is now coming to next will be like this. Should know that lambda is inversely proportional. It is inversely proportional to energy. If energy increases, wavelength decreases. If energy increases, wavelength decreases. And if energy decreases, wavelength increases. Okay, if suppose this is your wavelength, like this is your wavelength. Can you see the wavelength? This is one small wavelength, this is wavelength, this is there. So if this is how much, this is small, that is why energy is more. Wavelength is less, therefore energy will be more. Suppose if I draw it in this way, here you can see it has increased. Because it is increased, wavelength is more, energy will be less. Energy passed will be less. Okay, so here you can write lambda is inversely proportional to energy, therefore lambda 1 by lambda 2 is equal to E2 by E1. Remember this, lambda 1 by lambda 2 is equal to E2 by E1. Coming to frequency, what is frequency? Frequency denoted by mu, just now said. Okay, now number of waves in 1 second. Units is hertz, that is Hz. Okay, cycles per second also, cycles per second, this is also one unit, that is CPS. Coming to this, the relation between nu and lambda is, nu is inversely proportional to lambda. Okay, if nu is inversely proportional to lambda, then nu is directly proportional to energy. Nu is directly proportional to energy and inversely proportional to wavelength. Frequency is inversely proportional to wavelength. Means, when suppose if I ask you from this diagram, this is the wave, if I ask you this thing, can you see? And if I give you one more diagram which is in this way. Okay, now in the first one, if you see the first one, this is your wavelength, this is your lambda, right? This is your lambda. And in this second case, this is your lambda. These big ones are your lambdas, right? Now you can see here lambda is less, therefore energy will be more. Energy is more. And frequency, number of waves, see, number of waves are more here, therefore mu is more. When lambda is less, energy and frequency is more. When lambda is more, energy is less, therefore you can see number of waves are also less, that is mu is also less. So you can, just now we know lambda is inversely proportional to energy, lambda is inversely proportional to frequency. Clear? That's all you need to remember. And that is why we can write mu 1 by mu 2 is equal to E1 by E2. Since, why? Because mu is directly proportional, it is directly proportional to energy. Clear? Coming to velocity, what is velocity? I said velocity is either denoted by c or v. It is distance travelled by wave in unit time. Distance travelled by wave in unit time is nothing but velocity. Okay, so velocity of all electromagnetic radiations is same. Remember this point. Velocity of all electromagnetic radiations is same. This is a very important point you should remember. A very important point. Make a note. Velocity of all electromagnetic radiations is same. Okay, so for SI unit, what is SI unit? It is 3 into 10 to the power 8 meters per second constant, or else you can write for CGS unit, it is 3 into 10 to the power 10 centimeters per second in centimeters and meters. Clear? Now coming, you should know that what is the relation between velocity, frequency and wavelength. What is C is equal to nu lambda. This is very important. Velocity is the product of frequency and wavelength is nothing but velocity. The product of frequency and wavelength is velocity. The product of frequency and wavelength is velocity. Now it is from this here you can derive mu is equal to what? Lambda by C. C by lambda. Mu is equal to C by lambda, you can tell. Lambda is equal to C by mu, you can say. Alright. Now coming to wave number. What is a wave number? I will write here wave number, which is denoted by nu bar. Nu bar is nothing but wave number. So nu bar is nothing but 1 by lambda. 1 by lambda. Okay. Now nu is inversely proportional to 1 by lambda. Okay, nu is inversely proportional to lambda, but wave number is nothing but nu bar is nothing but equal to 1 by lambda. Number of waves that are present in unit length. Number of waves that are present in unit length, and unit for this is either in centimeter inverse or meters inverse. Now we had this, right? C is equal to nu lambda. So nu bar is nothing but 1 by C by nu. It is 1 by C by nu. Therefore nu bar is equal to nu by C. Okay, this is a relation between wave number, frequency and velocity. This wave number is equal to frequency divided by velocity. That means wave number is inversely proportional to velocity. Okay, wave number. If suppose velocity is less, the speed is less, velocity is less, what will happen? Wave number will be more. Correct? Now next we will go with the formulas. We have seen all the formulas, etc. Right? Now I have one question. You need to calculate frequency of radiation. You need to calculate frequency of radiation whose wavelength is 3000 angstroms. We know wavelength is given by angstroms. Let us solve. So you need to find the frequency. Means you need to find the nu. Nu is question mark. Lambda is 3000. What is the relation we know between nu and lambda? It is nothing but nu is equal to C by lambda. Right? So we know what is C. C is nothing but 3 into 10 to the power 8 meters per second. Alright? So we will solve it. Now, angstroms. We need to change, this is given in angstroms, right? We need to change this into meters because here it is in meters. For changing into meters, when angstrom has to change into meters, we need to multiply by minus 10 meters. 10 into minus 10. 10 into 10 to the power minus 10 actually. You should multiply. So what we will get, substituting this and this. So when we do this, we get nu is equal to what is C? 3 into 10 to the power 8. In lambda you should write 3000. Since it is in angstrom, for changing into meters we will multiply by 10 power minus 10. 10 power minus 10. It will become your meters. Okay, here it will be your meters. Here it is your meters per second. Now solve it. After solving everything, what will you get? When you solve, you will get answer as 10 to the power 15 hertz. You get the frequency as 10 to the power 15 hertz. Okay. So if you want, I will just explain how to do this. It is 3 into 10 to the power 8 into 1 by 3000 into 10 to the power minus 10. Alright, so we know this gets cancelled, 1000, and then 10 to the power 8, this will go up, no wait, 10 to the power plus 8, 1000 can be written as 10 to the power 3 into 10 to the power minus 10, which is 10 to the power plus 8. This 3 minus 10 will be 10 to the power minus 7. Okay, then you will bring this up, 10 to the power 8 into 10 to the power 7. This plus minus 7 becomes plus 7. Then this will be 10 to the power 15 hertz. You should write the units. These are very much important. Okay, one more frequency question we will do. Okay, one more frequency question. So the question is, you need to calculate frequency of radiation whose wavelength is 600 nanometers. So here you need to find the frequency question mark. Wavelength is 600 nanometers. Again, the relation is C by lambda. Nu is equal to C by lambda. C is nothing but 3 into 10 to the power 8 meters per second. Here also you need to change. For changing nanometers into meters, what we need to do, we have to multiply 10 to the power minus 9 into 10 to the power minus 9 you need to do. So let us solve. Substituting mu is equal to C by lambda. So mu is equal to 3 into 10 to the power 8. Lambda is nothing but what we got, 600 into 10 to the power minus 9. Okay, meters. Your meters and your meters per second. You just solve this, you will get, this is 3, this is 3 joules, and then what, just keep on solving. This is 10 to the power 8, 200 into 10 to the power minus 9. This can be written as 10 to the power 8 into 1 by 200 into 200. Here it will be 10 to the power 9, positive 9. Minus 9 becomes plus 9. Now you know this is this, how much it will be. You have 100 here, okay, so you will get something like 10 to the power 17 into 1 by 200, which is 10 to the power 17 into 10 to the power minus 2. So you will get answer as 0.5 into 10 to the power 15 hertz inverse second. Okay, second inverse. We will see next questions in our next video.